The topic to be discussed in this video is structural issues related to IoT. That means structural aspects of the aspects structural aspects of the IoT. First one under subheadings are environment characteristics, characteristics. Second one is traffic characteristics. Third one is scalability. Fourth one is interoperability. Fifth one is security and privacy. Sixth one is open architecture. First one is I will concentrate on environment characteristics. First one, environment. Under environmental characteristics, in IoT, IoT operations totally depends on things. Things are nothing but devices. Devices are equipped with some technologies perform their actions. First one is low power. Some of the devices are low power devices. That means small battery power. These low power means these devices are equipped with small battery power. Equipped with in IoT applications, some electronic devices are nothing but things that can be equipped with very limited power. Some applications refill of power source might be impossible. Therefore, that node, sensor node, or a thing or device lifetime strongly depends on battery lifetime. Therefore, most of the times, the thing or device lifetime strongly depends on the power consumption of that node. Suppose sensor node or any other device lifetime strongly depends on strongly depends on battery lifetime. If the battery discharges, in some applications, no way to charge that battery. Therefore, the node or device is in dead condition. That is the one of the constraint of the major constraint of the IoT devices. That is the low power. Low power batteries are equipped with the devices with the requirement that they will run potentially for years on batteries. Low power, but run with years of with run potential for years on batteries. Low power is the one of the constraint. That is the one of the environmental characteristics of the IoT devices. Second one is low cost. This is also one of the constraint of the IoT devices. The cost of the total cost is in a single digit dollar or triple digit rupees. Otherwise, sometimes more number of devices are needed for implement the applications, IoT applications. In such a case, that cost must be is under some limits. Otherwise, we cannot implement such type of important applications. Therefore, that is another constraint. Low cost. Total device cost in single digit dollars or triple digit rupees. Otherwise, the cost is more. We cannot implement the applications. Next one, very important. The very important one is limited energy supply. Limited energy supply. There is no way to charge the batteries. That is the reason have to limit the energy supply to nodes for processing their operations. Next one, limited memory space. These devices are equipped with some limited memory space. Limited memory space. That is sometimes we use flash memory and RAM, random access memory. RAM for fast data storage, internal flash memory for code storage. RAM for fast data storage, and internal flash memory for code storage. Executing codes are stored in flash memory. In most of the IoT devices are equipped with microcontrollers performing their operations, computations. And another constraint of that IoT device is computing capabilities. Computing capabilities. Computing. Generally, we use microcontrollers for performing computations. Generally, microcontrollers are low power devices. In some applications, we need DSP processors. DSP processors require more power for their operations. That is the reason that the DSP processors are not equipped with devices. But microcontrollers are some limited computing capabilities. These are the some important constraint of the IoT device under environmental characteristics. Environmental characteristics consider IoT devices, analyze the IoT devices performance. The IoT devices performance totally depends on subcomponents analysis. That means power equipment. That means related to battery, low power batteries, limited energy supply, computing capabilities, like etc. Consider generally we use for local connectivity. Local connectivity. This is under the environmental care. Environment means local connectivity is access one type of environment. How to connect the devices in that area. Suppose we use local personal area networks. Simple requirement for simple requirement for simple communication technology. Communication technology. That is IEEE 802.15.4 standard. Standard is very promising for the lower layers. Okay, these are the local connectivity. Sometimes some sensors are fitted on the body of the patient, sense the conditions of the patient, generate the data. In that situation, in local connectivity that is related to environment, how to connect these devices is the very important. These devices are connected with the help of a local personal area network, that is IEEE 802.15.4 standard. That is local connectivity. These device environment means how to interact these devices to environment is very important. Interaction involving a physical world. This is also environment characteristic. Interaction involving the physical world. This is also one of the environmental characteristics of the IoT devices. Next one is traffic characteristics. Traffic characteristics means we analyze the communication process. Analyze the communication process. That is okay. Traffic means data or information sent from one point to another point. First one is cellular mobile networks are designed for human communication. Nowadays, smartphones are playing an important role. That is the cellular mobile communications provide more traffic to other persons. Cellular mobile communications. Cellular mobile networks are designed for human communication. Human communication. Communication is connection centric. Communication is connection centric. Suppose between humans, the traffic is voice and video or data communication. Between humans, the traffic is voice, video, or data communication involving humans. That means web browsing, like downloads and so on. Sometimes with the help of cellular mobiles networks, send the voice information and video information from one point to another point. Video information by using WhatsApp applications. Voice means by using a telephonic conversation between two peoples with the help of cellular mobile networks. And also data communication involving humans. Or web browsing. Suppose if you want to search for an important application by using some web browsing, file downloads and so on. Important is that cellular mobile networks are optimized for traffic characteristics of human-based communications and applications. Cellular mobile networks are play an important role. Next important point here is suppose billions of devices are connected into the internet in IoT applications. Most of the times, some of the devices are not involved in communication, but power is on. In some cases, only small messages are sent from one point to another point. At that instant only, these devices some of the devices are involved, but power is on. But these devices lifetime totally depends on power consumption. Without power, all these devices are battery operated. Okay, suppose the device is involved in communication or any other information is sent from one point to another point, some power is consumed. Communication process, under communication process, more power will require to send the information from one point to another point than computation process. Computation means execution of instructions. In that case, we will require less power. That is the one of the aspect that is related to traffic characteristics. Suppose no traffic when the system is in sleep mode. Suppose how to save the power is the one of the important, crucial, challenging task. Research task. How to save the power. No traffic. Suppose no traffic. When the system no traffic when the system is in must be in sleep mode. Sleep mode means that device is not involved in any other communication. Okay. With the burst of communication, suppose the device is involved in communication. When an event occurs, that means the device is triggered. It involved in burst of communication. Event occurred is very important. The device is involved in a burst of communication. When the device is triggered, there is no traffic when the system must be in a sleep mode. When the device is triggered, triggered means traffic is there. At that instant, when the device is triggered or an event occurs, sleep mode is converted into active mode. Therefore, the device is involved in communication. Device used for IoT application will most of the time be in sleep mode, only sending small amount of traffic to notify the rest of the networks that is still functioning. Generally, most of the times in IoT applications, the device will be in sleep time. Will be in sleep mode, only sending small amount of traffic to notify the rest of the networks that is still functioning. At that instant also some power is wasted because the power module is in on conditions. On the other hand, when it is triggered means an event has been occurred, some burst of communications will take place. At that instant, some power is wasted. These are the some important points related to traffic characteristics. Cellular mobile communication networks are play an important role in case of traffic characteristics of IoT. Smartphones are involved. Smartphones are used by the persons, send the voice and data information to another persons through cellular mobile communications networks. Cellular mobile communication networks. Another important structural aspect of the IoT is scalability. Scalability is a plain important role. Suppose sometimes we need to extend the IoT networks. Sometimes we have to delete some devices. Sometimes we have to add some devices to performing their extra tasks At that instant, the scalability in IoT is the ability of a device to adapt. To adapt means to accept the changes in the environment and meet the changing needs in the future. That is called as scalability. Changes the network's functionalities. If you want to add more devices to the network or remove the device from the network, that is called as scalability. The scalability in IoT. Scalability is the ability of a device to adapt to the changes in the environment and meet the changing needs in the future. Scalability will be key to handling the explosive growth in the IoT. IoT applications must have the ability to support the things, support the features. An increasing number of connecting devices, users, application features, and analytic capabilities without any degradation in the quality of service. Suppose that is scalability means add something, delete something. If you add something, means some burden is there. If deleting something means some important information is not processed. But some of the devices have ability to accept such type of addition and deletion of the devices. Compatible with such type of aspects. Next one. When the contemplating expansion, one wants to be able to build an previously deployed technology without having to scrap the system and start from scratch. Suppose any person wants to establish a new IoT technology or new IoT applications with the help of a previous system and analyze the previous system performance and use that such parameters to build the new IoT system. The efficiency of a large system should be better than the efficiency of a small system. Is very important point on the scalability. The efficiency of a large system should be better than the efficiency of a small system. Suppose large system means for a particular applications require 20 sensor nodes, sense the environmental characteristics, temperature or crop characteristics, humidity, temperature, growth, soil content, positions like that. Such a situation will require 20 sensor nodes. Instead of 20 sensor nodes, 10 sensor nodes are available. Therefore, 10 sensor nodes are not enough to sense the field conditions, examine the crop conditions. That is called 10 sensor node is nothing but small systems. 20 sensor nodes are nothing but large systems. Therefore, the efficiency of large systems should be better than the efficiency of a small system. This is also under scalability. Next one important structural aspect is interoperability. Interoperability. Suppose in IoT, in IoT applications, different types of IoT devices are involved, different types of platforms are there, different types of IoT networks are there, different types of systems are there, technologies are there. IoT supports interoperability means enable communication between heterogeneous devices or systems, platforms or networks in order to achieve a common goal. Heterogeneous means different kinds. Different kinds means different types of networks, different types of devices. Some of the devices are intelligent devices, some of the devices are not intelligent devices, like that. Interoperability enables communication between heterogeneous devices or systems. Heterogeneous device means some of the devices are sensor nodes, some of the devices are smart devices, like that. Heterogeneous devices are systems, platforms or networks, in order to achieve a common goal. IoT interoperability can be seen from different aspects, such as different aspects. Interoperability can be analyzed with the help of different aspects, such as device interoperability, device interoperability. Second one is networking interoperability. Syntactic interoperability. Semantic interoperability. And platform interoperability. Interoperability means allow the communication between different types of heterogeneous. Different kind means heterogeneous devices, platforms and networks, to achieve proper goal. Next one, device interoperability. device interoperability. High-end devices and low-end devices. Two types of devices are there. High-end devices, low-end devices. High-end IoT devices have enough resources and computational capabilities, such as high-end devices, more capabilities than low-end devices, such as Raspberry Pi. Raspberry Pi and smartphones. Smartphones are high-end devices. In case of low-end devices are resource constraints. What are the resource constraints? Already explained in the first one. Environmental characteristics, low power battery equipped devices are there, and limited memory, limited processing capabilities, such as RFID tags, low cost sensors. All are belongs to low-end IoT devices. Low-end IoT devices are resource constraints. IoT devices are resource constrained. Resource constrained in terms of energy, processing power, and communication capabilities. Next one is a network interoperability. Different kinds of networks are used for exchanging their information between the devices. IoT interoperability means allow IoT platform supports different types of networks or different types of networks to allow to exchange information from one point to another point. But in case of network interoperability based on addressing, totally based on due to dynamic and heterogeneous network environment. Due to dynamic means changing the network topologies time to time, and heterogeneous means different kinds of devices are used in IoT. The network interoperability level should handle issues such as addressing, routing, optimization or resource optimization, not routing, resource optimization, security, quality of service, and mobility support. Next one, syntactical interoperability. Syntactic interoperability refers to interoperation of format as well as the data structure used in any exchanged information or services between heterogeneous IoT system entities. Different frame formats are used in some cases. In some cases, different types of data structures are used. Syntactical interoperability means interoperation of the formats as well as the data structures used in any exchanged information or service between heterogeneous IoT entities. That is called as a syntactical interoperability. Syntactic interoperability allows two or more systems to communicate and exchange data. However, the interface and the programming languages are different. Operability means allows, anything allows. Suppose one system follows, some of the devices follows some programming languages, some of the devices follows another programming languages. These devices are attached to different types of networks. But in case of syntactic interoperability allows two or more systems to communicate and exchange data. The interface and programming languages are different. Even next, semantic interoperability. Semantic interoperability. Semantic. The data is not only exchanged between two or more systems, but also understood by each system. Semantic interoperability. Semantic, that means different types of data structures are available. Semantic interoperability, the data is not only exchanged between two or more systems, but also understood by each system. Next one is a platform interoperability. Platform operability issues in IoT arises due to the availability of diverse operating systems. Operating systems are play an important role in case of platform interoperability of the IoT devices. Programming languages, data structures, architectures, and the access mechanisms for things and data. These are the under platform interoperability. Some of the in wireless sensor networks we use tiny operating systems. Some of the operating systems are example is tiny operating system for wireless sensor networks. Generally, the microcontroller architecture and key system characteristics of IoT device such as processor speed, RAM, communication technology, and battery capacity differ broadly between different brands and models. Generally, microcontroller play an important role, and RAM, communication technology, battery capacity, all are the important uh, characteristics of that devices. Next one, security and privacy. Suppose most of the IoT applications such as electric power distribution, goods distribution, transport and traffic management, e-health, and other key applications, the security is very, very important. Electrical power distribution, goods distribution, transport and traffic management, e-health, and other key applications. In such cases, security and privacy is very, very important. It is critical to maintain system-wide confidentiality identity integrity, and truthworthiness. That information need not open to other third-party persons. Suppose in goods distribution follows, one company follows one strategy. You have to maintain some privacy, security and privacy. Other than that information is leaked by third-party person, definitely that another company follows that one. In chemical formula, you have to in case of open architecture, last one. The goal is to support a wide range of applications using a common infrastructure, preferably based on the service-oriented architecture. Service-oriented architecture. Over a open service platform. These are the some structural aspects of the IoT.